Good morning everyone, I am Mr. Rish. Thank you for joining me for this video. A quick one, but we are going to mathematically prove a vector quantity multiplied by scalar quantity is always equal to a vector quantity. I'm using abbreviations there, V for vector, S for scalar. A vector multiplied by a scalar, that product is equal to a vector. And remember, vector is a quantity which has two dimensions or two attributes. It has the dimension of magnitude and direction. A scalar only is a unidimensional property having magnitude. Let's look how we go about doing this utilizing a good, simple, but to the point example. You know you can decompose this vector into its magnitude and into its direction. What's the magnitude? The magnitude is always your v1 plus your v2, your individual components squared, and then the square root of those. You're doing square of this plus square of this, the sum of that, you're doing the root of that. You'll have 4 plus 4, you're looking at root 8, and then you're having 2 root 2. When you do the angle of that, the angle of a vector, the direction which is represented by that angle is always your arctan, your y component divided by your x component. Here you can say your v2 component by v1, because here I'm looking at a v1 and a v2, the individual components that make that vector. You're looking here at a 2 over 2, but in terms of its arctan, and you know you're going to get pi over 4 or 45 degrees. And now you can represent this vector, which was originally designated as this by means of two dimensions, your magnitude, which I'm writing right here, 2 root 2, and then you can put your angle, your direction, cosine pi over 4, and then sine pi over 4. That's how I've shown you that I'm starting out here with a item, which is indeed a vector. It has a magnitude, your scalar quantity, and it has direction, which is your angle over here. Now I'm looking at this vector, and let's look at this part right here. Vector times a scalar is equal to vector. I have this vector, I'm going to multiply it by a scalar quantity. Let that quantity be a. A could have been a numerical number, 0, 1, 2, a negative number, anything. And then your end result is this AV. That's what I have. So how do I show this in this format? I'm looking at this, it's going to multiply with 2 root 2 and then cosine pi over 4 comma sine pi over 4. That's what I have. For additional meaning, why don't I make a equal to a value? Let a value be 2. It's nothing wrong with me bringing in a substitution here just to make it a little more relevant. So when I'm doing 2, which is your a value, which is your scalar multiplied by a vector should equal to a vector, and that's what we're going to show you over here. Well, we'll multiply it across. We'll have a 4 root 2, and then we're looking at cosine pi over 4, and then sine pi over 4. That's what we have, and this represents now your end result, your vector. How can we represent that vector in a different way? Well, you can multiply everything across this. You can distribute this scalar quantity, which is your magnitude, across the direction and recreate this new modified vector. We will call the new modified vector v prime, and then that v prime here is going to represent this end result. It's going to be equal to what's cosine pi over 4, sine pi over 4. You know it's always equal to cosine of 45 and sine of 45, which is 1 over root 2. You're doing 4 root 2 times 1 over root 2. That's your x component, and then your y component is 4 root 2 times 1 over root 2. You complete this, you're having a 4 comma 4, and that right there will represent your new modified vector. All of this could very well have been easily demonstrated using this step right over here. I have a vector which I am multiplying by a scalar quantity which I showed you was a equals 2. I'm really looking at a 2 and then 2 comma 2, which when you compute it is 4 comma 4. Here you have clearly shown that you're starting here with a vector. You multiplied here by a scalar quantity which was 2, and you ended up with a vector end result. And I'm showing you that over here. And just remember very much mathematically that a vector quantity multiplied by a scalar quantity is a vector quantity, and I've shown that to you. And that's it. Thank you for watching. Have a good day.